Okay guys, today we are going to take a look at algebraic proofs. So we're going to start our proof writing with a tie to what you already know about, and that is some algebra. For this you're going to need that handy dandy reference sheet, or both of them if you want both, especially the algebraic properties part, and also some note templates which are kind of handy because they're already organized in a chart form, and that chart form is what you're going to see me using today. So get out your handy dandy reference sheets, okay, because we're talking about using properties today, and sometimes you might not know the exact name for the property, and you can use that reference sheet to help you out. So this is the first proof we need to make sure that we can get into our notes. It says, given that 2x plus 6 equals 8 minus x, we are to prove that in fact x equals negative 14. So for each and every proof, you're going to be given a piece of given information that you know about, and then also something that you're supposed to prove, so your end goal. Now for this, we know for sure, or for certain, that we are given an equation, and we can go ahead and use our solving skills to prove the end result here. So the first thing you want to write is that 2x plus 6 equals x minus 8. I'm just going to write this in the given box so it matches your notes. And then prove, our goal is to prove that x equals negative 14. Every time you write a proof, you want to start with a given piece of information. We have to start somewhere. Something has to be given to us. So in the first statement we're going to write in our proof is that we know for certain that 2x plus 6 equals x minus 8. And how did we know that? Because that was given to us as being a fact. That is a certainty. And then from there, we take our algebraic skills now and try to solve to reach this end result. This is our goal, to try to get x to equal negative 14. So you're still going to use your algebra skills. We may not show every step here as we're doing this, but we are going to justify every step as we go. So for instance, if I want to solve for x, I might choose here to first subtract that 6, right? So that I can start getting x alone. So maybe you would do that first. If you subtract the 6 from both sides, you'd get 2x equals x. Now remember, I'm subtracting 6 on the other side, so negative 14. What did we just do there? Well, we did the subtraction property of equality, which says if you want to subtract from both sides, you can do that as long as you remember to subtract the same thing on both sides of the equal sign. So this is subtraction property of equality. And the of equality is important because there are other things you can do, you know, especially with addition. You can have angle addition, segment addition, things that you add or subtract other ways. But when we're adding or subtracting and solving an equation, we want to make sure we're saying we're using the property of equality that makes that happen. Okay, so now let's look at where we're at in step 2. We have 2x equals x minus 14. Well, my next step would probably be to get the x to the other side here so that he can be together with a 2x, so you might subtract him off. That would leave you with a negative 14 here and just 1x on the other side. So again, we use the subtraction property of equality. Now, we're justifying every step that we go through. So notice, yes, you had to show that step where you subtracted a 6. You could have done this a different way, however. Let's say you wanted to start by adding the 8. You can do that. Your step in your proof, however, would have to reflect that you changed that method. So if you added 8, you would use an addition property of equality to make that happen, okay? So be thinking about that. There's more than one way to justify or write this proof. We just have to be certain our justifications are in fact correct and we didn't skip any steps. Let's look at this second one. We are given two pieces of information here. We are first given that 2x minus 5 equals 4x minus 7. We are also given that x equals y. And our goal is to prove that y equals 1. So the very first step in every proof, again, is to start with my given. 2x minus 5 equals 4x minus 7. And you might think, wow, this one looks just like the other one. I have to just solve. But be careful. Notice in this proof, we have an equation given to us with x's, and my goal is to try to prove that y equals 1. See, that's where that other piece of given information comes in. This says that x equals y. So sometimes you have more than one piece of given information. You may have to account for that in your proof. So we have the equation 2x minus 5 equals 4x minus 7, And we also know that each x is the same or equals the y. Well, notice what we want to prove has a y in it. Y equals 1. So my given equation that I'd want to solve, I don't want it to have x's in it. I want it to have y's. So I can change every x into a y because step 2 says that x's are the same as y's. So we'll go ahead and change every x into a y. What is the property that allows me to do that? Substitution. Substitution allows me to do that because I basically substituted I put a y in for every x, or I've taken every x out and replaced it with a y. That's the substitution property. Now, substitution, sometimes people like to make a note what two steps they kind of combine to win their substitution. So you might see 1 and 2 after that in a proof. They took step 1, substituted in what they knew from step 2, and then got this new equation. So now that we have that figured out, now we can go ahead and start solving this. So maybe let's do this time. Maybe look at this -7 over here. I would maybe want to start solving by adding that 7. So my proof would look like 4y, and then I would add 7 here to that -5, so it would become 2y plus 2. So then I would say I use the addition property of equality. Cool. And then I would go, well, now this is looking pretty good, but I'd want to bring those y's over, right? So I would subtract 2y from both sides, and it would become 2 equals 2y. And notice we subtracted the 2y's away, so we'll say that that was the subtraction property of equality. And now, last but not least, we still have to divide by 2, right? And you get 1 equals y, and this is the division property of little pause there, of equality. Nice. Now what? Now what? Are we done? Look at what we're trying to prove above. Look at what we're trying to prove. Now, guys, did we prove what we were setting out to prove? It says prove that y equals 1, and I proved that 1 equals y. See, this is where those other properties come in, because even though you might be thinking that's the same thing, we are not done until our proof step looks exactly like it was supposed to. So yes, I do need to say in another step that y in fact would equal 1. And what is the property name that lets me do that? That is the symmetric property. And remember, we talked about those. We talked about those symmetric properties of equality again. Nice. Okay, so we've written our proof here. We've finished up. We got to that end goal of what we were trying to prove. So now let's do one more that has a few more pieces of given information in it. Okay, a few more pieces of given information. So we have a given piece of information that C plus D equals an F. This one's a little different. Be ready. We have an F equals an H, and we have a C equals a D. And we're trying to prove that an H equals a 2C. So our very first step in any proof, you guys, write that given piece of information. C plus D equals F. In fact, we have multiple pieces, so I'm going to say the F is the same as an H, and the C is the same as a D. And next to the justification for each and every one of those, we're going to place given. These are 3 pieces of given information that we started with. And now if we look at our next idea or our next thought, what are we trying to prove? Somehow we need to get in it something about an H and something about 2 C's. So far what we have doesn't have anything to do with 2 C's. I don't even have a number in here. Coefficients are all 1. So maybe the first thing you'd want to do then is look for things that have C's in there. Well, the first one here has a C and the second one here has a C. Well, it says a C is the same as a D, so couldn't we substitute those two again and maybe write what a new equation might look like? So if the C is the same as a D, I'll take the D out of the top one and replace it with a C so I can get two C's in something. So that would be the substitution property. And again, sometimes it's nice to make that little note what you're doing. That was step 1 and step 3 that I sort of combined together there. And now, you see we have C plus C, but we want it to be 2C. So is C plus C the same thing as 2C? Yeah. So we can just simplify that. And if that's what we did, then let's say we just simplified. Okay, we simplified line 4. There we go. Now the next thing we'd want to do is take a look at trying to get, an H in there, okay? Because we're close. We have the 2C and now we need to get an H in there. Now that guy right there and this guy right here, kind of handy right there. Could you substitute again? Sure. Could you use the transitive property? Yes, okay. Both of those would be fine. So maybe we then would say 2C's would equal an H, and we could say that we used the substitution property, or you could say the transitive property of yeah, in this case. Either way, they would both work. So substitution property is the one most people choose here. So we would say, which lines were those? I'm looking back, 2 and 5. I combined together. Lovely. And now we're getting close. We're pretty close. We were supposed to prove that H equals 2C, but we have 2C equals H. So we'll just flip-flop those guys around again. And what allows us to do that is that symmetric property. Awesome. Okay. So this is your first look at some proof writing with some algebraic expressions. Notice no geometry figures are in here yet. We need to get the hang of writing these justifications and always making sure that we have a reason for what we're saying. Then we'll get into that proof writing when we're looking at geometry figures and it'll make a little bit more sense. So I want to thank you for taking good notes today and we'll practice when I see you, okay? Thanks.